So let's see what are the things that we learned last week. We learned that under raw rubber processing technology, we learn how to manufacture raw materials out of natural rubber latex. So in this module, we will be discussing about how latex is processed in a way that you could make different products. So in the next module, we will be doing how to produce, how to design it, how to massively produce different products based upon the processing technologies that we learn here. So under this one, we have several topics. That means first, we will be discussing about the stability of latex. Then we will learn about how compounding is done. Then we will basically talk about what are the types of processings that you can do for latex in order to manufacture goods. Finally, we will be doing latex that is manufactured from synthetic rubbers. Okay, even synthetic rubbers, we have latex. So we could discuss how to process synthetic latex in order to get different products. So as a easy for understand any latex system, if you learn about natural rubber latex, so we will first cover all the necessities of natural rubber latex and processing. Then we will move into synthetic rubber latex processing. Okay, so today we will be coming to the lesson number 2, that is latex as a colloidal system. Okay. Can you all see the screen?
Yes, madam.
Okay, so we will move. So topic number 1, latex as a colloidal system. So now when we talk about colloidal system, I suppose this word is new to you. Is it so? Colloidal system, the word colloidal, is it new to you? මේ කොලොයිඩ් කියන වචනේ අලුත්ද දන්න එකක්ද? Okay, I suppose you all don't know, because even for other degree programs, we talk about colloidal systems in the degrees at this level. So when we want to learn what is a colloidal system, and we should know what are the different material distributions in different other materials. Okay, when one material is distributed in another material, we could get different types of systems, such as solutions, suspensions, and colloids. Okay, when one particle is distributed in another, you call it a dispersion. Okay, generally this is a dispersion when one particle is homogeneously or inhomogeneously distributed in another liquid material, basically we call it a dispersion. Now, even though we broadly classify them as dispersion, now solution is a special type. Now, in the solution, usually when you add a particle into, suppose it's water or any other liquid, that means even toluene, oil, any liquid material, if you put a particle, and if that particle is disintegrate into the atomic or molecular form and distribute as a homogeneous one solution mixture, we call it solutions. So such examples are when you add salt into water, what happens? Salt will be disintegrate into sodium plus, chloride minus, and homogeneously will be distributed in the water, and it is inseparable. The distribution of particles So this particle distribution is in the scale of atomic or molecular level. Okay, so in a solution, you will not be able to separate the mixed ingredients or distributed ingredients by simple filtrations or other advanced filtration techniques. But there are other systems where particles are dispersed in another liquid material as a particle. Okay? තේරුණාද? සමහර particles අපි දැම්මහම වතුරට හරි එහෙම නැත්නම් වෙන ද්‍රවයකට ඒවා හොඳට දිය වෙනවා හරියට අණුවක් දිය වෙලා යනවා වගේ විඝටනය වෙලා දිය වෙලා යනවා. විඝටනයට වෙනවා කියන්නේ integrate වෙනවා and it is dispersed. Such ones are solutions. So this is one ideal situation. But suppose you add sand into water. What will happen? Sand will not dissolve in water, it separates. But if you add some soil sample to water, what happens? කතා කරමු පුතා. මොකද නැත්තම් ඔයාලට මේක තේරෙන්නේ නැහැ. පස් වතුරට දැම්මොත් මොකද වෙන්නේ?
dispersion වෙනවද?
දිය වෙනවා වගේ. එහෙමනේ. It will become brown in color and you will get a solution type 1 also. But what happened to the that tea color solution that you have? With the time, soil sediments down in the bottom of the container where you collect it, into which you are collected. So such type of ones we call suspensions. Okay, such type of systems you call suspensions. In suspensions, these particles are very big, so that up until a certain degree, it is suspended in water, but with time, due to gravity, these particles are pulled down and settles. So this is mainly due to gravity actually. Okay. So the particle sediments. Now in the case of particle being very small, the weight is minute, so the gravitational force is negligible compared to the other forces acting upon a particle. Now, what are the other forces that act upon a particle? When you put a particle into water, Archimedes found that there is upthrust So if a system has a particle size where upthrust is equal to gravity, what will happen to the particle? Will it separate or will it sediment? අපේ particles පල්ලෙහාට එන්නේ උඩට යන්න තියෙන force එකට වැඩිය පල්ලෙහාට එන්න තියෙන force එක වැඩි වුණොත් නේ. උඩට යන්න තියෙන force එක තමයි upthrust එක. Upthrust එක කියන්නේ මොකද්ද? උඩුකුරු තෙරපුම. Okay? If you have more upthrust, if your weight is lower than the force generated by upthrust, then the forces will be balanced. So sedimentation will become slower and slower. So in such systems, you will have a stable suspension and it is not separable under normal circumstances. So such type of systems, we call it colloids. So that is why even though colloid is a dispersion of particles in a liquid phase, it does not show sedimentation as a normal scenario. Okay, so it visibly appears as a solution, but actually it is not a solution, because solution, usually the particles has to disintegrate and become their respective ions or respective molecules. Now, why I say molecules? When you add lactic acid or acetic acid, විනාකිරි වතුරට දැම්මොත් මොකද වෙන්නේ? Solution එකක්ද හැදෙන්නේ, suspension එකක්ද හැදෙන්නේ, colloid එකක්ද හැදෙන්නේ? කියන්නකෝ බලන්න. If you put vinegar into water, which type of a system do you think is building inside? Is it a solution, suspension, or a colloid? අර පොඩි කාලේ ඉක්මනින් උත්තර දෙන්නේ. ඒ විදිහට උත්තර දුන්නොත් we could move on. Otherwise, we cannot move because I cannot see you guys now. Oh. Dinoshi, Minoshi, Pasindu, Chamir, all in one?
Yes, madam.
Where are you? One moment, I have a...
At university, madam.
Okay. So, in the case of colloids, as I said before, it looks like a solution. Even though it is not a solution, colloids are always looks like a solution. Now, before that, just tell me the answer for that acetic acid or vinegar dissolve in water. You put vinegar into water. What will happen to the system? What type of dispersion will you get? Quickly answer, then we will be able to finish off the lecture. This. Okay, I will give the first chance to the group. Dinoshi, Minoshi, Pasindu, Chamira. 4 people. One of you unmute and tell me which type of a system dispersion will you get when you disperse vinegar in water?
Madam, colloid. Excuse me, madam. Excuse me, madam.
Yes, Chamira. It's Chamira, right?
Yes, madam. Colloids.
Okay, Hiroshima, can you tell me, Puta, what do you think? Hiroshima? Mahisha, what do you think, Mahisha?
Yes, madam. Colloids.
Okay. Now, as I said before, solutions are when a particle is disintegrated into their molecule or their respective ions. So ions should be ionic solids, right? So it should be crystals like sodium chloride, copper sulfate. Then they will become copper 2 plus and sulfate 2 minus and disperse in water as a solution. Now, in the case of acetic acid or vinegar, these are again polar molecules. They half integrate. Okay, they're not fully disintegrating. They will be half integrated. That is why I said they are in their molecular form. Okay, as an acetic acid molecule, it is dispersed inside the inside water as a solution. Okay, but in the case of colloids, they are particles which is in the size of 1 to 100 nanometers in typical definition of colloids. So this has to be a solid or a liquid or a liquid particle which is immiscible. Yes, Puta, can.
Madam, අපිට තාම පේන්නේ introduction slide එකනේ.
Yeah, Puta, I'm still there. I didn't move on. Okay, so you want to come this way. This fellowship. Now, in the case of colloids, it is in the particle. So it is not going to be disintegrate as its ion or to the molecule, but as a particle itself. So now I will be giving you the definitions of solutions. That is a liquid mixture in which the major component is uniformly distributed within the major component. Now this, you have to remember these words. This one, minor component and the major component. Now, in the case of chemistry, we don't need these two words, major and minor components, but as a polymer student, you should know what is a minor component and major component. Now, as the word itself means, minor component means what is present as small amount. Major component is what is present in larger quantities. So usually this minor component is called solute and major component is called solvent in a solution system. Okay, in a solution, something is dissolved inside a big quantity of another material. So this one is solvent, which is in bigger quantities. The one that is being dissolved inside is called solute or the minor component. Okay? තේරුණා නේද? So when you talk about this minor component, these minor components are very small, usually in the size of ions or in simple molecules. So it will be dispersed inside the solution as a single system. Okay, so it is not separable under normal filtering techniques. Sodium chloride you can separate only if your solvent is being evaporated. Acetic acid, that of course you cannot do. You have to go for purification, like reduced pressure distillation or distillations. Sugar also you can separate through removal or how do we remove the solvent from a solution? By evaporation. So evaporating water, you can get a sugar crystal, but in most cases it will be caramelized. So you have to control the temperature. So likewise, you need to evaporate the solvent in order to get the solute back. So such type of systems you call solutions. Okay. The example I have already talked with you. Either you can dissolve a solid in a liquid like sodium chloride in water, copper sulfate in water, sugar in water, all are solutions. Liquid also dispersed in another liquid such as acetic acid, vinegar, ammonia, what else? Lime juice. So all these are liquids and they are solutions. So you can make a solution out of solid dissolving in liquid or liquid dissolving in another liquid. Now, when you talk about liquids, there are two types of liquids. One is you can mix with the solvent. The other one is you cannot mix with solution, with the solvent. So such types, you have to have a phase separated system. We will talk about these systems later today. Okay. Second system is suspensions. As I said before, when you put a soil sample into water and stir it vigorously, soil will suspend in water and make dirty water. Okay. So the suspension usually looks like this. This one, and upon settling or keep it undisturbed for a certain period of time, you could see all the particles sedimenting in the bottom. So this is called sedimentation. Okay. There is a similar process which is called precipitation. Okay. There is a similar process, but actually it is not what happens here. This is solid particles suspended in water is settling. This is called sedimentation. But in the case of chemical reaction, if the reaction produces a solid particle due to reaction, the particles that produce will be precipitated in the bottom. So the two words should not be interchanged. තේරුණා නේද? ඔගොල්ලෝ chemistry උගන ගන්නකොට chemistry lectures කරනකොට precipitates කියන වචනයක් ඉගෙන ගන්නවා. මෙතනදී ඒ precipitate කියන වචනේ පාවිච්චි කරන්න බෑ. precipitate එකක් වෙන්නේ අපි දාන chemical reaction එකක් වෙනවා නම් අපි system එකක් ඇතුලේ chemical reaction එකක් වෙලා solid particle එකක් හැදිලා ඒ හැදෙන particle එක පල්ලෙහා තැම්පත් වෙන එකට තමයි කියන්නේ precipitation කියලා. ඒ වුණාට මෙතනදී වෙන්නේ බර හින්දා settle වෙන එක මේකට කියන්නේ sedimentation. Okay, you have to clearly remember these words. Okay, now in the case of suspensions, as I said before, if the particle sizes are bigger, then weight will be more bigger in magnitude so that it will sediment. If the particle is very small, upthrust will balance the weight of the particle so that the sedimentation will not occur. Usually, these particles are in the range of 100 nanometers to below. You will definitely not get any type of sedimentation. But in the case of some particles, we can go up to 1 micrometer. I will show such colloid system. Okay, in a colloid system, you have a particle homogeneously distributed in another phase or another substance. Usually the diameter is 1 to 1000 nanometers, as in the case of organic liquids are involved. If inorganic particles are there, you have to have 1 to 100 nanometers, because we know that inorganic particles are heavy sometimes. Most of the time it's heavy. So this is a play between upthrust and weight, right? So if you have higher dense particle, in order to counterbalance with upthrust, the weight has to be, the size has to be small. But in the case of organic colloidal systems, we can go for 1 to 1000 nanometers. Okay, specifically for inorganic systems, 1 to 100 nanometers. But in the case of proteins and other hydrophobic liquids are involved, you can go up to 1 to 1000 nanometers particle size. So in a colloid, mostly it looks like a solution, but it is not, because you have particles evenly distributed inside the solution. For one example is milk, the other example is latex. Third example is blood. Okay. You have milk, latex, and also blood. It is a colloidal system. So usually these particles dispersed inside the solvent is insoluble. Okay. They are usually insoluble particles, and also even under normal conditions, they are inseparable by filtering. Why? Size is still small. Only suspensions can separate through filtration. Okay, so based upon the type of the minor component, there are different colloidal systems called sols, emulsions, foams, and aerosols. Okay, 4 types of colloidal systems are there based upon the nature of the minor component: sols, emulsions, foams, and aerosols. What is this minor component? Just now I explained what is the minor component. Minor component is the particle that is dispersed in solvent. So based upon the quantity of the components, two components, you call minor component and major component. So in the milk, you have protein as the minor component, fat and protein in minor components. Major component is water. So it is the solvent. So let's see what are these salts, emulsion forms, and aerosols. It's getting late. Okay, so before going on into what are they, these are the examples. Milk, natural rubber latex, blood, paints that you use to paint your walls, and also the paints that you use to paint arts and other surfaces. They are also colloidal systems. You have fog. Fog means tiny water droplets dispersed in air. Okay, so the major component of fog is air. Minor component is water. You have different types of cosmetics. The girls use all these type of cosmetics. They are most of the time colloidal systems. Okay. Boys, in the morning, shaving foam. It's a colloidal system. Beer glass, you have the beer foam forming on the top. Again, it's a colloidal system. The whipped cream or cream that is used to decorate your desserts. Again, a colloidal system. Detergents, colloidal systems. So you have come across many colloidal systems in your daily life. Now, think about how many systems you came across from the morning to now. There are so much. Okay, if you come in the morning, you come across fog. You have the boys shave. In the morning, you shave your faces. Shaving foam is there. Milk is there. Then you might come across different other food products that is based upon colloidal systems. So now, when you think about milk and lime juice is a solution, whereas milk is a colloidal system. So basically, this is the difference between colloidal systems. Okay? තේරුණාද? බැලු බැල්මට මේ දෙකම එක වගේ. ඒ වුණාට වෙනස්කම් තියෙනවා. අරක separate කරන්නම බෑ. හැබැයි colloidal systems, after instability occur with time, you can separate. Example, milk. කොහොමද curd හදන්නේ? Separation of two phases. Colloidal system is destabilized. Rubber, you all have learned. What is occurring in rubber? With time, what happened? මේක ගෙන තියෙනවානේ. ඔට්ටපාලු එහෙම හැදෙන්නේ කොහොමද? That is called destability of latex. I know Dr. Susantha has already taught to you. කොහොමද rubber phase separation එක වෙන්නේ latex එකේ? මොකද්ද mechanism එක? මතක නැද්ද? පසින්දු. මොකද?
Centrifuge mechanism.
Putrefaction.
Centrifuge.
It's putrefaction or spontaneous coagulation. That is where instability occurs. අපි centrifuge කරනකොට අපි unstable කරන්නේ නැහැ. අපි කරන්නේ separate කරන එක. Unstable වුණොත් ආයි අපිට stable කරන්න බැහැ මේ systems, because these systems, upon instability, the particle size will be going up. So you will not be able to disperse back into their original colloidal situation. සමහර වෙලාවට මේ cream, whipped cream beat කරනකොට වැඩිපුර beat වුණොත් මොකද වෙන්නේ? මේ ලස්සනට තියෙනවද මේ විදිහට? වැඩිපුර beat වෙච්ච ගමන් මේක දිය වෙනවා. ඒක තමයි whipped cream වල art එක. හරි? Unstable වෙනවා, unstable වෙච්ච ගමන් ආයි ගන්න බෑ. So this is the compare and contrast of solutions, colloidal solutions and suspensions. In a true solution, it is homogeneous mixture of solute and solvents.
Excuse me, madam.
Yes, පුතා.
Madam, ඇහෙනවා ටිකක් මැද lag වෙනවා madam. ඒ voice.
දැන් ඇහෙනවද? මොකද current නෑ මම පුතා මේකෙන් යන්නේ. මං ඉන්නේ mobile band එකකින්. මම mobile broadband එකකින්. ඒකේ lag වෙනවා ඇති. Anyway, I hope the recording might be clear, but make sure you come to the lecture even though I put the recording, okay? Okay, now in the case of true solutions,
Okay, madam.
okay, true solutions, these are really homogeneous. Okay, you cannot separate it by filtration. But in the case of colloidal solution, it appears to be homogeneous, but actually it is heterogeneous mixture. Now, what is homogeneous and heterogeneous means? In homogeneous, the dispersed agent, dispersing agent, both in the same state. But in the case of colloidal systems, as I said, mostly it is going to be a solid particle dispersed in a liquid or solid particle dispersed in air, or else immiscible liquid is dispersed as tiny droplets in another liquid or in air. So immiscible means they have two different phases. So if you have two different phases, that is called heterogeneous. So that is why we call the colloidal system to be heterogeneous, mixture of solute and solvent, but it appears to be a homogeneous type into your eye. ඇහැට පේන්නේ liquid එකක් විදිහට. ඒ වුණාට ඇත්තටම liquid එකක් solution එකක් නෙමෙයි. Now, in the case of suspensions, Okay, it seems like when I put this full screen mode, it disturbs the system. So we will do the lecture now like this. Now, in the case of suspensions, they actually is heterogeneous. One is a particle which is readily separable. So it is heterogeneous. Now, in the case of true solution, they are transparent, but in the case of colloidal systems, it is translucent and suspensions opaque. In the third one, the solute particles are very small in true solutions. And in colloids, it is typically between 1 to 100 nanometers in the case of inorganic particles. If they are something like proteins and fats, which is lower weight, you can go up to 1000 nanometers in particle size. And the suspensions, you have bigger particle size. Usually for inorganic substances, it is more than 100. But for milk and latex type of particles, it's more than 1000 nanometers. Can you see me and hear me? ඇහෙනවද? පේනවද? Okay. So do I need to explain everything here? Usually in a true solution, the particles are non-separable, so not visible. But in the colloidal system, if you use a microscope, you can see the particles and suspensions. Certain suspensions, you can even see it from your naked eye. The fifth point is when you filter it. Can you hear me? Can you hear me, Buddha?
මැඩම් ඇහෙනවා ඇහුනට පොඩ්ඩක් මේ පොඩි ලැග් එකක් තියෙනවා.
මට මේක වැඩ කරනවා පෙන්නන්න. Okay. Let's see. Now, again, when I talk about true solutions, if you pass it through a filter paper, that means if you filter, whole solution will pass through the filter paper. In the colloidal system also, everything will pass through the filter paper. But if you use a semi-permeable membrane, membrane එකක් use කරවුවොත් ගොඩාක් small particle distance එක interparticle distance එකක් තියෙන membrane එකක් ඒ වගේන් යන්න නැති වෙන්න පුළුවන්. Okay, if you use a semi-permeable membrane, through such membranes, the colloidal solutions could be separated. Suspensions, they will, only the solvent is passed through a filter paper. So definitely you can filter and clean or separate the solvent and solute from a suspension. You usually call it major component and minor component when it comes to suspensions and colloidal systems. Sixth point is solute particles do not show Tyndall effect. Now, Tyndall effect is a characteristic optical effect for colloidal systems. So, for colloidal systems, you have Tyndall effect. Suspensions, they can show Tyndall effect. Also, in certain instances, they may not show the Tyndall effect. Seventh point is true solutions, even after a longer period of time, the particles will not be separated due to gravity because they are already disintegrated into their relevant anion and cation or into the molecular form. So they will not settle. But in the case of colloidal systems, they will not separate under gravity, but if any other external force occur onto the colloidal particles and making the particle sizes bigger, then they will sediment. That's all. Suspensions, they will sediment or settle due to gravity upon time. Okay, so let's see what are salts, emulsions, and forms. Now, sol means in a colloidal system, you have a major component and a minor component. Yes or no? You have a dispersing agent and a dispersing medium. Dispersing agent is minor component. Dispersing agent is major component, or usually what you call it as solvent. Now, in the sol, suspension of very smaller particles, you call minute solid particles, in another liquid, you call it sol. Okay, in a sol, you have minor component is solid, major component is liquid, or we call it the solid particle is the dispersing agent. Major component is called as dispersing medium. Okay, second type is emulsion. In an emulsion, you have two types of liquids as dispersing agent and dispersing medium. Now here, what happened? This one is dispersing agent, okay? Solid particle is dispersing agent, liquid is dispersing medium. The spelling mistake, when I saw it's C, not D. Now here you have two liquids. One is immiscible with the other. Okay, so the major component and minor component are immiscible and dispersing phase or dispersing medium will be a liquid, and dispersed media or the particle is an insoluble liquid. As a form of a minute droplet, it is dispersed inside. Okay, so you can have a system like this. You have the what is this? One second. Okay. You have small droplets inside, then you will have an immersion. Remember, immersion is two immiscible liquids. Now, in the case of latex, natural rubber latex and milk, both are categorized under emulsions because the
Madam,
dispersing.
excuse me.
Yes, Pata, can.
मैडम मैं करंट එක ගිහලා තියෙන ලැප් එකේ බැටරි නැහැ मैं ලිව්වේ मैडम मैं LMS එකේ course page එකක් නැහැ latex වලට
ඔව් අද හදාන්නම් පුතා. මොකද ඊයේත් මට පොඩ්ඩක්වත් මේ කරන්ට් තිබ්බට ඊයේ මොනවා හරි ප්‍රශ්නයක් වෙලා ඉන්ටර්නෙට් තිබ්බේ නැහැ. මං ඊයේ සතියේ I had a problem with corona, so I was out.
मैडम मैं recording එකක් දාන්න පුළුවන්ද मैडम मैं log වුණා දිගටම
දානවා, don't worry.
thank you madam.
Okay, right. So in the case of emulsions, you have immiscible droplets. Immiscible liquid droplet is dispersed. So milk and natural rubber latex both are considered as emulsions. Third type is foam. In foam, you have a gas, tiny gas bubbles dispersed in solid or a liquid. You will form a foam type one. Then the last one is aerosols, where you have minute liquid droplets dispersed in gas or minute solid particles dispersed in gas. So examples of aerosols is morning fog. Foam, examples for foam is you have foam mattresses, you have whipped cream, shaving foam, all are foams. Emulsion examples, milk and natural rubber latex. Okay, so let's see what are the properties of, oh, it's already 10, right? Okay, for today, since we don't have power also, I don't have a good internet connection here. So we will stop for the day. I will make the course page today evening. Let me do it in the evening because I have to go to the university. After, if you have anything to be clarified, then you can call me and ask. One more thing I have to tell you. This is not based for the lecture, so I will remove the recording.